Position vectors. Vectors are usually represented by directed line segments. So it's a line segment because it's just part of a line, and it's directed because it has an arrow. Position vectors start at the origin, so the vector tells us how to get to a point on a plane. In many regards, this is equivalent to coordinates. So if you understand coordinates, you should understand position vectors. So the origin is shown here by O. Here's a point A, and this vector is showing us how to get from the origin to the point A. The vector is called small a, and note how when it's typed, it's bold. When we write them by hand, there's various ways that you can do this. I usually just underline a vector like so, but you see people underlining with tildes, you see them overlining, you see them actually putting arrows above or below. There's all of these different notations. Just stick with this one. That's the one I use. So to elaborate upon that and look at some other ways that we can represent vectors, that position vector could also be represented as OA. And note here, when we represent it as OA, the arrow does point this way, so it shows that we're going from O to A. If the arrow went the other way, we'd be talking about going from A to O. And of course, that's not a position vector. Position vectors start at O. We could represent it as A, as we've said, and that's when it's typed, they're bold. So usually handwritten as A underlined, which was the way I said. You'll see other representations, as we discussed. In the textbook that you have, you'll see this representation with the arrow above. I mentioned that one before. But I would just get used to writing them as A underline, as I've said before. There are other representations you may find in other books and online. Just be aware that there's no one set notation that's used for handwriting a vector. So here we have a grid. And let's say we're considering the point A, which is at 4, 5. And we know how that works, 4 across this way and 5 up. We could represent it by this vector A. And A is 4 across in the x direction. Note I've written that as 4i. We'll come to that in a moment. And 5 up in this direction. Note I've called that 5j. The vector I is a vector that's 1 unit long in the x direction. A vector that's 1 unit long is known as a unit vector. So I is a unit vector in the x direction. Hence, to go 4 units across this way is 4i. J is a unit vector in the y direction. And therefore, to go upwards 5 units is 5j. So we can say that OA is 4i plus 5j. To go directly here, we just go 4 across and 5 up. In vectors, it doesn't matter whether you go via this route or direct. That's called unit vector form. There are other forms. We can say that OA is 4, 5, and that's called component form. And this is my favorite form. I tend to use a column vector, as this is known, to represent my vectors. But you need to be aware of both. So we could also represent that as A is 4, 5, and of course A is 4i plus 5j could also be written. For a general point P with coordinates x, y, OP is equal to xi plus yj, or in component form xy.